जय श्री राम सभी फ्रेंड्स। आज लेक्चर 8 में हम बात करेंगे कूलॉम्स लॉ, परमिटिविटी और एक न्यूमेरिकल देखेंगे। लेट अस स्टार्ट। नाउ व्हाट इज कूलॉम्स लॉ? सी दिस in this particular there are two different types of charges. One is positive, other is negative, or both could be positive. So like charges repel and unlike charges attract, as we already know. Now the question is how much force is applied between the two charges. For example, there are two charges q1 q2 at certain distance r, they are placed. So in vacuum the force magnitude is given by this F is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square, where k is a constant which is 1 upon 4 pi epsilon naught, right? Now this is equal to 9 into 10 to 9 Newton meter square per coulomb square, right? Now see, another important thing is how to define this epsilon. This is called permittivity, which is 8.85 into 10 to 12 coulomb square per Newton into meter square. This is called the permittivity of free space. Now, what's the meaning of point charges? Coulomb's law is valid for point charges. Means when the size of charged bodies are much smaller than the distance between them, then the charged bodies are called point charges. So, important concept, let us understand. First of all, there are different properties of charge. For example, two charges exert equal and opposite forces on each other. For example, there are two charges shown here which exert two forces. So they form action-reaction pair. Follow Newton's third law. Next, Coulomb's force is central force. Means they act along the line joining the centers of two bodies. As you can see this particular diagram, this is the line joining the center of two forces. Third point is Coulomb's law follows inverse square law. Means force is inversely proportional to force is inversely proportional to r square. And the points to be remembered, that is Coulomb's force is long range force. Means from nuclear dimension, means r is equal to 10 to the minus 15 meter to very large distance, which is 10 to the 18 meter. So this is long range force. Next is Coulomb's force depends on the medium. As we can see in vacuum, the force magnitude is say F, and in say water, if this system is merged in the water, then the water, this force becomes 1 upon 80 times that in case of air or vacuum. So Coulomb force is a conservative force. The work done against these forces does not depend on the path. These are certain points which are to be remembered in concern with the Coulomb's law. Now, what's the meaning of vector form of Coulomb's law? Till now we have seen the magnitude of the Coulomb's law, that is F is equal to 1 q1 q2 upon r square. Now see, let us elaborate more. If the distances are, so there is a unit vector defined, which is r cap r12 cap, and another is r21 cap. The two are just opposite to each other. Now, what's the meaning of r12? We can easily understand this is nothing but a unit vector in the direction q1 to q2. Similarly, r21 is just opposite to this. Similarly, we can define f21 means force on charge q2 due to q1. This is q1 and this one is q2. So there are two different forces which are equal and opposite to each other, and accordingly the distances which are calculated in the direction of the unit vector. So f21 becomes 1 upon 4 pi epsilon naught q1 q2 upon r square into the unit vector. So unit vector is used to show the direction of that particular force. Similarly, we can define f12. F12 is 1 upon 4 pi epsilon naught q1 q2 upon r square into r21 cap. Okay. Now, what is the meaning of this or importance of the vector form? So the vector form of the Coulomb's law gives addition function in the sense that if r2 cap r21 is nothing but minus of r12, both the unit vectors are equal and opposite to each other, therefore f21 is equal to minus of f12. Okay, so two charges exert equal and opposite forces on each other. So Coulombian forces obey Newton's third law of motion. Second is important thing, Coulombian forces act along, that is F12 or F121. Okay, that is along the line joining the centers of two charges. So they are central forces. As you can see in this diagram, this is the line joining the center of the two charges. So forces are applied along this line joining the centers. Okay. Similarly, here see there are two charges q1 q2 at a distance r. So F is 2 Newton, then this is also 2 Newton. Okay. Now, what are the limitations of Coulomb's law? Electric charges must be at rest. Second is the electric charges must be point charges. And third important point, the separation between the charges must be greater than the nuclear size, that is 10 to the minus 15 meter, because for distances less than 10 to the minus 15 meter, the strong nuclear force dominates over the electrostatic force. So these are three different limitations in concern with the Coulomb's law. Now, what is permittivity? Permittivity is property of medium which determines the electric force between two charges situated in that medium. Next, suppose F21 is the force on charge Q2 due to Q1, that is 1 upon 4 pi epsilon naught Q1 Q2 upon r square R12. Okay. So epsilon naught is 8.85 into 10 to the minus 12 Coulomb square per Newton meter minus 2. Okay. So this is called permittivity. What is dielectric constant, or you can say relative permittivity? So the dielectric constant or relative permittivity of medium may be defined as the ratio of the force between two charges placed some distance apart in free space to the force between the same two charges when they are placed the same distance apart in the given medium. For example, epsilon r, or you can say k, is defined as the ratio of epsilon and epsilon naught, or you can say this is the ratio of force in vacuum to the force in the medium. Okay, so force in the medium is nothing but the force in vacuum divided by k. For example, you can see the different values of K, which is equal to K is equal to 1, dielectric constant is 1. Okay. For air, this is 1.00054, and for water, it is 80. Okay. Now, see one numerical problem. This question says the two identical charges Q each are kept at a distance R from each other. A third charge is placed, Q is placed on the line joining the above two charges such that all the three charges are in the equilibrium. What is the magnitude, sign, and position of charge Q? See, this is the diagram which is showing the language of the question. Okay. A and C are two situations, one location at which capital Q charges are placed, and in between at point B, a small charge Q is placed. Let this distance X, which is from A. Okay, so distance between A and B is X, and between A and C is small r. Now, Q will be in equilibrium if forces on it by the charges at A and C are equal and opposite, isn't it? So you can say you just equate the two, means the forces should be equal. So K into Q means for A and B setup. This is K into Q into Q upon X square is equal to the K into Q into Q upon R minus X square. So this condition must be satisfied. Okay. So from this you can find out the value of X, which is nothing but X is equal to R by 2. Okay. So means the third charge Q must be placed just in mid of the line joining the centers of two charges. Now, K is repelled by C because it is same charge, so A must be attracted by Q for equilibrium. So therefore, Q must be negative. First, in case for first part, the answer is this. Second is the force of repulsion. As we have decided, the force of repulsion between A and C is equal to force of attraction between A and B. Okay, so you just equate the two forces, that is K Q into Q upon, yeah, in this equation you just put the value of X. Okay, so you are getting K Q Q upon R upon 2 pi square is equal to K Q into Q upon R square. From this, so you are finally getting Q is equal to capital Q by 4. So this is the solution of this question. Okay, so this is all for today's lecture. I hope you get it, and I will see you in the next lecture. Till then, Jai Shri Ram.